MSBTE online learning platform. We bring you the most relevant content in an exciting digital format. Today, we will studying a very interesting module from the applied mathematics, first order, first degree differential equation, which includes topic of formation of differential equation, where we will be studying some interesting fact about order, degree and formation of differential equation, and we will be practicing some of the example based on it. So let us begin. Dear students, welcome to the session of the subject Applied Mathematics M2 Unit 4, and module is Differential Equation. Topic is formation of differential equation. Learning objectives. Learning objectives is at the end of this unit, you should be able to form a differential equation from a given function. Learning outcome is one should be able to form a differential equation from different function. Formation of differential equation. To form a differential equation, we differentiate the given function and remove the constants. Example is, form a differential equation with y equals to then cx square. Solution for this one is, differentiate both sides with respect to x. We get dy by dx equals to then d by dx of cx square. Dy by dx equals to c into d by dx of x square. And here we are going to take constant term outside, that one is keep in mind. So derivative of x square here is 2x, and hence the right hand side is 2cx now. Let us remove the constant c by putting c equals to y by x square in that expression. Dy by dx equals to then 2 into then y by x square into x, and here we are going to take that x get cancelled from this one, and then your term we can get here as 2y by x. Answer is x dy by dx minus 2y equals to 0. Now when we conclude here, answer is here x dy by dx minus 2y equals to 0, we can transfer this term on left side. Second example is, verify that y equals to a raised to x plus b raised to minus x is a solution of d square y by dx square minus y equals to 0. And before taking the solution, my dear students, you must know the derivatives of e raised to x and e raised to minus x. Keep in mind that is standard formula for d by dx of e raised to x at the e raised to x and e raised to minus x at the minus e raised to minus x. And now we come to that solution of this example as y equals to a e raised to x plus b e raised to minus x, which is given in the question. Differentiate with respect to x. Now dy by dx, we are written here on the right hand side d by dx of a raised to x plus b raised to minus x. And here now, this is a expression containing, we are going to apply one rule. That rule is d by dx of u plus v, and hence by using that rule we come to this one here, d by dx of a e raised to x minus b e raised to minus x. So next step is d by dx of y equals to a e raised to x minus b e raised to minus x. And keep in mind that students, that is always you make a mistake in this particular step. That one is d by dx of e raised to minus x equals to then minus e raised to minus x. Keep in mind that one. Oftenly students make the mistakes here because they know the derivative of e raised to x as e raised to x, and hence keep in mind that derivative of minus e raised to minus x. So d square y by dx square equals to then d by dx of a e raised to x minus b e raised to minus x. Again, d square y by dx square equals to then a e raised to x minus b e raised to minus x. Again, when the student writes the next step, there will be some mistakes in these two signs. As earlier, you know that one here, that when we take two negative sign indicates that one is a positive there, and hence we can write the next step here as, see here, that is a plus sign. That is a plus sign. Positively we must say that one is a e raised to x plus b e raised to minus x now. Now we come to that last step here, but can you guess the answer for that one? Yes? See, that answer is now here. Again here we had written that derivative of d by dx of e raised to minus x as a minus e raised to minus x. Now we put that value of e raised to x plus b raised to minus x because this is our original expression, and we can write here as d square y by dx square minus y equals to 0. Hence we can come to the conclusion here that this y equals to a raised to x plus b raised to minus x is a solution of d square y by dx square minus y equals to 0. Next example is, find the differential equation from the relation y equals to then a e raised to mx. Solution for this one, y equals to then a e raised to mx. Differentiate this expression now. So d by dx of y equals to then a d by dx of e raised to mx. So dy by dx equals to then, now here we can take that a constant then, and we can take derivative of d by dx of e raised to mx. This is again here, it is not a standard form, this particularly, and hence we can apply one rule here as m into e raised to mx, because formula is e raised to x. Then again we simplify that right hand side, m a e raised to mx. Naturally m a are constant here, and again e raised to mx, that equals to then y. It is again given in your question then, and hence we can say again differentiate dy by dx of dy by dx equals to then m a into d by dx of e raised to mx. So d square y by dx square equals to then m a into bracket m e raised to mx, because earlier we take the derivative of e raised to mx as e raised to mx. Same condition we can apply repeated here, and hence we come to the right hand side here again as m square a e raised to mx. So can you guess the answer for this example? Yes? The answer is d square y by dx square minus m square y equals to 0. How we can get that answer again here particularly? this is m square y, and when we transfer that term on left hand side, that sign is changed, and mostly we can say that when students are making mistake for transferring that sign here. Now solution for this example is, it is given that expression as y equals to a sin x plus b cos x. Differentiate with respect to x then. So d by dx of y equals to then a into d by dx of sin x plus b into d by dx of cos x. Now here we are going to use one rule, a into d by dx of sin x plus b into d by dx of cos x, one of the rule which is given in derivatives. So again here keep in mind that one is derivative of sin x is what and derivative of cos x is what, because it is given in the standard form, and hence we can say that one dy by dx equals to then a cos x plus b of sin x. Now here keep in mind carefully, that is derivative of sin x is cos x plus b into then minus sin x, and again here mostly the student can make a mistake by taking the derivative of cos x, because in the student's mind that is derivative of cos x is sin x. So finally we can get on the right hand side there is a cos x minus b sin x. So again differentiate this one, and hence we come to that next step here as dy by dx equals to then a into d by dx of cos x minus b into d by dx of sin x. Again we can apply same formulae, just in place of 1 second and in place of second, that is 1. And see now again here derivative of cos x we are going to take in the previous step, and derivative of sin x we can take in the earlier step, and hence we can write that one d by dx of dy by dx equals to then a into d by dx of cos x minus d by dx of sin x. So therefore d square y by dx square equals to then a into minus sin x minus b cos x. So if we take that sign is common here, why? Because there are two minus signs inside bracket. First term is negative, second term is negative. Again student make that mistakes here also, and if we take that minus sign is common, then we can write it as a minus y. Again we can transfer that minus y on left hand side, so that finally we can get the answer of this one. Can you guess that answer? Yes, students? See, that answer is d square y by dx square plus y equals to 0. Now for this answer again, see your problem when we solve d square y by dx square equals to minus y, and when we transfer again that minus y on left hand side, that should be positive here. Now next example is, verify that y equals to then 4 sin 3x is a solution of differential equation d square y by dx square plus 9y equals to 0. Solution for this one is, that expression is given already in your question. We write that one as y equals to then 4 sin 3x. If we differentiate this one, we can get that one as the dy by dx equals to then 4 into d by dx of sin 3x. Now this is sin 3x is not a standard formula, but by using that d by dx of sin 3x and we apply some different types of derivatives in that one, we can take derivative of d by dx of sin 3x easily, and that one is here. We can say 3 cos 3x. See here, that one is derivative of 3 cos sin 3x is 3 cos 3x. Again we are going to differentiate this one. D by dx of dy by dx equals to then 4 into d by dx of 3 into d by dx of cos 3x. So therefore, d square y by dx square equals to 4 into then minus 3 into bracket derivative of cos 3x. Derivative of cos 3x, just as earlier we take derivative of sin 3x as a 3 times sin x. In a similar fashion, we are going to take derivative of cos 3x, but keep in mind again there one thing, that is there is a negative sign is important. And at d by dx of cos 3x, we have taken here 3 sin 3x with that minus sign on the left of this expression. So therefore, if we simplify again that step, we can take that minus 9 is outside this bracket, here see that, into then 4 sin 3x. Now your answer for this one is minus 9 into then y. Again we can say that is 4 sin 3x as the value of y here, and we can write that one as d square y by dx square minus 9y. Recap with objectives. So recap with objectives now. At the end of this unit, you should be able to form a differential equation from a given function. So function may be any types, definitely the students can form the equation easily. Conclusion is, at the end of this unit, you should be able to form a formation of differential equation. Yes, dear students, have any question about this?
Yes, sir. Why we are not able to find derivative of a given function?
Very good question. Because lack of confidence about that your list of formulae for finding the formation of differential equation, because everywhere in every step student must know the derivative of each and every function, because they don't know which formula we can apply in this particular expression. Are you understood it?
Yes, sir.
Are you satisfied or not?
Yes, sir. Thank you.
Now you are fully competent to solve the problem of differential equation. So worksheet is given below, try to solve it. Your example, easy example is here given. Verify that y equals to cos x is a solution of x d square y by dx square plus y equals to 0. So y equals to cos x, it is given already in your expression. So differentiate with respect to x then. So dy by dx equals to then cos x. That dy by dx equals to then minus sin x. Now here, see here that one is, student makes a more mistakes for writing this step always, because derivative of cos x is minus sin x, and they don't know that one is we are going to take minus sign here. Why we take minus sign? Because this is the derivative we are going to take here, and hence we can write dy by dx as a minus sin x. That is our equation 2. Again differentiating that equation 2, now we can say d by dx of dy by dx equals then minus d by dx of sin x. As far as rule is concerned, we take that minus sign here as minus outside this d by dx of sin x, and hence we can say d by dx of sin x. This is again a standard formula, keep in mind that one again. So d square y by dx square, which is equals to then minus cos x. So d square y by dx square must be equals to then minus y, because always y equals to cos x is given in that your equation. So can you get that answer? D square y by dx square minus y equals to 0 here. So verify that our example is again verify that y equals to cos x is a solution of x d square y by dx square plus y equals to 0. Solution for this one is y equals to cos x, differentiate with respect to x. dy by dx equals to then d by dx of cos x. So dy by dx equals to then minus sin x. Here we had written that formula d by dx of cos x equals to then minus sin x, and we apply that one is here as minus sin x, and mostly the student make the mistakes here. When we writing that derivative of cos x, they can write only sin x. Keep in mind that one is minus here because formula says. Again differentiating d by dx of dy by dx equals to then minus d by dx of sin x. So on left we can take d by dx of dy by dx equals to then minus d by dx of sin x. So d square y by dx square equals to then minus cos x then. And that value of cos x, it is already given as a y, and hence we can say d square y by dx square equals to then minus y. Verify that y equals to then log x is a solution of x d square y by dx square plus dy by dx equals to 0. So again, keep in mind that there is only one derivative in this example. Solution for this one is y equals to the log x, differentiate with respect to x, dy by dx equals to then d by dx of log x, and derivative of log x is 1 by x. Then if we multiply this one, we can get here x dy by dx equals to 1. Again differentiating, we can say there d by dx of x dy by dx equals to d by dx of 1. So here derivative of constant function, as I told, that one is derivative of any natural number, we can say that is 0, and we can write here as a d by dx of x dy by dx. Then next step says x dy by dx of dy by dx plus dy by dx into d by dx of x. And here we are apply that product rule for this one. And so after simplifying this step, we can get that is x d square y by dx here plus dy by dx equals to 0. Moderate example, verify that y square equals to then ax square is a solution of x of dy by dx h square minus 2y dy by dx plus ax equals to 0. Solution for this one is then y square equals to ax square, differentiate with respect to x. So now d by dx of y square, again here that student can make a mistake because that one is fully not in mind, that one is what is the derivative of y square, because this is one of the implicit function, and we can say that one is 2y dy by dx equals to then d by dx of ax square, as we earlier apply a rule here as a into d by dx of x square. So that is twice y dy by dx equals to then twice ax. Now here 2y dy by dx equals to, we can modify this step as a twice ax, so that 2 get cancelled. We can get y dy by dx equals to ax. So y dy by dx equals to x, and from this one dy by dx equals to x upon y. This is the very useful values for the future step. Then putting the value of dy by dx equals to ax by y in the given expression, which is already, this expression is given in our question, and we are going to put simply dy by dx equals to ax upon y in this expression. And see here then, x dy by dx is square minus 2y dy by dx plus ax, it is given expression. We can write that one here as ax into ax square upon y square. Why we write that one ax square upon y square here, and a is just like this one? Because in future now we are going to know that one is this value of ax square upon y square must be that one is again y square upon y square. So minus 2y into ax upon y plus ax. So now this a we can take inside. If we take that a inside, then that is we can say this is a square x square upon y square, and for that a square x square we take that is y square. This one is a tedious step for the student is concerned, and hence I am going to explain here again as a into a square x square as it is, y square as it is, because ax a square x square means that is ax equals to y as our equation given, and that is we can write here a square x square upon y square minus 2x plus ax. We can take simple addition here. Then we can say that finally here we come to that one as ax into then y square upon y square minus ax. Ax, this get cancelled, minus x equals 0. Hence y square equals to ax square is a solution of x of dy by dx square minus 2y dy by dx plus ax equals to 0. Then moderate example, then verify that y equals to then x upon x plus 1 is a solution of 1 plus x dy by dx plus y equals to 0. Now solution for this one is y equals to then x upon x plus 1 is the given expression. We are going to either say multiply by x plus 1 here, see here y equals to then x upon x plus 1 is given, either we can say multiply or divide. So your expression is x plus 1y equals to x. This is our equation 1. Then d by dx of x plus 1 into y. Again here we can say that is differentiate this one with respect to x then. We can differentiate this one with respect to x on left hand side, and that right hand side is only d by dx of x. So we can say x plus 1 into dy by dx. This is a product rule we can apply here. This is the first function, this one is the second function, and hence we can write first function as x plus 1 dy by dx plus y into d by dx of x plus 1, that is equals to then 1. So answer is again here x plus 1 dy by dx plus y minus 1 equals to then 0. Simply we can transfer this 1 from this right hand side to the left here, and due to that one, after transferring any term, whatever it may be on right hand side, we can transfer it, then that sign should be opposite to that right hand side, and that is here. If there is a positive sign, we can write minus 1. If there is a negative sign, we can write then that is positive sign. So next example is show that y equals to then sine of log x is a solution of differential equation x square d square y by dx square plus dy by dx plus y equals to 0. Solution for this one is y equals to then sine of log x. Differentiate with respect to x then. So dy by dx equals to then d by dx of sine of log x. Again, oftenly students make more mistakes by taking derivative of such type of example. So d by dx of sine of log x is not a standard form here, but we can apply the base of implicit function here. So we can say that is derivative of sine only. This is the variable, and hence we can write cos of log x, and again we are going to take derivative of log x as a 1 by x. So we can say that one is next one is here multiply by x. Again x is there, so we can multiply this as we are written here x dy by dx equals then cos of log x. So this is again next expression. Again same step we can use here. Again differentiating. So d by dx of x into dy by dx equals then cos of log x into 1 by x. So x d by dx of dy by dx plus second step is again dy by dx into dx upon dx, that is equals to then minus sign. Again keep in mind that one is minus sign. Always student makes more mistakes here by taking that sign, because the derivative of cos we take minus sign, not log x. Log x is variable here, we can read it as it is, and again we take derivative of log x as 1 by x there, so that we can get x d square y by dx square plus dy by dx equals then minus sign of log x into 1 by x. So by multiplying, now last step is a very simple one because already answer is given in your question. So keep in mind that one is, if we multiply this one, you can get that answer easily, x square d square y by dx square plus x dy by dx minus sign of log x, that x get cancelled here. Simply y remain on the right hand side, and if we transfer that one to the left, that answer we can get. Are you getting that answer? So x square d2y by dx square plus x dy by dx plus y equals to 0. Next difficult example again. Form the differential equation if x equals to a sine of kt plus b. So solution for this one. So this is again one of the different type of example. Keep in mind that student here variable are we can change. That is, in place of x we are going to take y on left hand side, and in place of x we are going to take t on the right hand side. And here keep in mind that capital A and capital B is always constant, and that k is arbitrary constant here. So we can say now your x equals to a sine of kt plus b. Differentiate this one with respect to t again. Dx by dt equals to a into d by dt of sine of kt plus b. Note that one again. We come to that one is a into d by dt of sine of kt plus b, because we can say here x is a function of t, and now we can say derivative of dx by dt as a cos of kt plus b into d by dt of kt plus b. Keep in mind again here. See here, we had written that particular step here, as because students make that lot of mistakes here. Simply here I am going to say a and b are constant, means naturally just like a natural number that b separately there is no variable, and hence we can take derivative of b is 0. So we can say d by dt of kt as a k into d by dt of t. So a into cos of kt plus b into k, because that one is k is here, we can say k we can take outside because both are constant. K a cos kt plus b, this is second equation. Again we are going to differentiate this one, d by dt of dx by dt, k a into d by dt of cos kt plus b. So d square x by dt square equals to ka. Again we come to that particular point, minus sign. Always make a mistake. Most of the students, I say that it is not most of the students, 80% students make the mistake of minus sign. So that is ka into minus sign of kt plus b into k plus 0, and that is we can say here that is minus k square a sine of kt plus b, that minus k square, and this value of sine of kt plus b as the x then. Finally we can get answer as a d square y by d square equals the plus k square x equals to 0. So recommended next topic is differential equation. Topic is solution of differential equation. Thank you. You have learned some important topics so far, as we hope you had a good time learning with us. Browse through our online library for more content on the MSBTE website. Thank you. Stay connected. Happy learning.